worksheet to solve some of the equations that we've been working with, or that we're going to work with today. I literally went through all of these textbooks and couldn't find one. So I followed it up with the stuff that we would do for pre-calc next year and looked through all of these textbooks and still didn't find any. So what we're going to do is, we can get rid of this. I literally went through, and the packet that you picked up in the beginning was just a simple, yeah, let me get rid of this. It is a review of stuff that we're going to be able to answer at the end. But that's just from a basic introductory algebra book. One of the things, though, that you have to keep in mind, and it's nice because there's some review questions and stuff that we'll get to. So we'll not rush through it, but make sure you just have a foundational knowledge of what we're doing. The second thing that you need to know is, for this unit and going forward, I am a huge believer in finishing early and going through and spending the last month-ish to review. The problem that we currently have is, according to our schedule now, we're going to have about 8 to 10 classes of review, as opposed to the normal 20 to 25 that I like to have. So we're going to do as much as we can to combine topics, and if that means some days we don't have an assessment, then we don't. But we're going to have to go through and make sure that we work at a little bit of a quicker pace and combine 2 days into one wherever we can. Taking a look at what's here, we're going to start off the day with one of pretty much the most important things that you can go through and get from this class. And it has to deal with what a rational exponent is. If I have some base raised to the b over c power, what that means is this number right here indicates your power. This number here indicates your root. So this would be the c root of a raised to the b power. Now, so we're all talking about the same thing. This number in front, we'll call it the c value. This is your index value. It tells you what level of root you're taking. And the other component is we need to recognize that this right here is the power. Now, we're going to get into some really fascinating discussions about what different roots are, but understand, taking the fifth root of 32 is not the same as dividing 32 by 5. You're asking yourself, what times itself 5 times gives me 32? Now, the other end of it is, especially as enriched students, you're supposed to have a vague number sense. Hands up, please, if you can tell me what the fifth root of 32 would be, or what times itself 5 times is 32. You should not need a calculator as an enriched student to answer that question at all. What is the fifth root of 32 going to be? 2. Now let's answer this question. What is the fifth root of negative 32? Hands up, please, when you can answer that. You've got to think. You've got to process what was just asked of you. What is the fifth root of negative 32? Because when we got our first answer, I did not correct something that perhaps some of you thought I should. No. Negative 2. Remember this. No. You're asking yourself what times itself 5 times gives you negative 32. If the index or root is odd, you can have a negative radicand. So think of it this way. What times itself 5 times is going to give me negative 32? And that would be negative 2 times negative 2 times negative 2 times negative 2 times. Because you can take the negative odd root of a number. Something like this. What if we have the cube root of 8 and the cube root, don't write this down, of negative 8? Hands up, please, if you can tell me what the third root of 8 is. You don't need a calculator to do. You have to have some sort of intellectual curiosity here in number sense. What do you want to say? What's the third root of 8? 2. It's not plus or minus 2. Because what is negative 2 being raised to the third power going to be? Hands up, please, if you can tell me. What's negative 2 raised to the third power? Negative 8. What is the third root of negative 8? Hands up, please, if you can answer that. Chloe? Perfect. Hands up, please, if you can tell me what the fourth root of negative 16 would be in the real number system. There is not one. And I said in the real number system, so we're not tinkering around with i's. There is not one. It doesn't exist. Because if the radicand is negative, you can't take an even indexed root of it. And when we say an indexed root, that's right there. Now, does this exist? Hands up, please, if you can answer that. Does that exist? We got one person. Who can tell me what that's going to simplify down to in simplest radical form? Shut down right away. We ask one little bit of a jump of a question. What is that going to simplify down to in simplest radical form? Trevor?
2 radical negative 2.
No. Here, let's do this. What is this equivalent to? How can I break this up?
8.
Other way around. Because what's the perfect cube that goes in there that settles most of this?
2.
Negative, 2 isn't a perfect cube root.
8.
The negative 8 is, right? Because then we dealt with the negative sign and the biggest perfect cube factor. So what is this going to simplify down to be? 2 cube roots 2. That's the stuff we're tinkering with today. There's one little piece we're going to talk about later about exponential growth and decay. But we need to recognize that it's power over root when it's in rational form. The index is what's going on the outside. And by the way, this you could also rewrite as the c root of a being raised to the b power. So that power can be in the radicand or outside of it. It will not impact your answer. And it seems like the Common Core is asking many questions that relate to those two and that notation. Questions on there? Now, as we work our way through, hopefully this will go quickly. If this expression is equal to 3 to the n power, what's the value of n? Hands up, please, if you can tell me what n would be if that's what the power, if that's what the radical notation is. What would the exponent notation be? Jonathan? Over what?
2 over 5.
2 over 5. Take a look at the next one. You need to understand this. If the index is, we'll say this. If the exponent on a term is not filled in, who can tell me what is the implied exponent? What's the implied exponent? 1. Now, if the index on your radical is not filled in, does anybody know what that's the same as? What's the index if it's not filled in? We've got 2 people. Tyler? 2. So looking at that, who can tell me what the square root is as an exponent? Hands up, please, if you can tell me. What's the square root as an exponent? If you were to convert that from radical notation into an exponent, what's the power over root going to go through and be? We've got 3 people. 4. Trevor, what do you think? What's the power that the x is being raised to? Right here? That's right. Look at the square root function. What's the power? What's the root?
2.
So what's that going to be as a fractional exponent?
1 over 2.
Now, looking at what we have over here, if that's our expression, this is really, and that's raised to some notation. We're getting out of exponent notation and into radical notation. This right here is the same as x to the 1/2 being raised to the 7th. If that's the case, hopefully if you did your homework from the other day, this makes sense. Who can tell me what the n value would be, or what is that as a combined single radical term? What's that? What is it as a fraction? What? Yeah. And we need to make sure when we're doing this out, you give a very clear, we're going to be working with fractional exponents, and if it gives you the decimal, I want you out of the decimal. Taking a look at this one here, if that's the case, go through and tell me what the x and y values are going to be. Looking at what's there. Jonathan, what is the x value going to be?
3.
And what's the y?
2.
Next one up. What is the x going to go through and be? Colleen? And what is the y? Evaluate out each of these without a calculator. Leave it in simplest fractional form. You may use your calculator to check. But this should not be your primary source of finding the answer. Now, I'm going to start off with this. I see 0.6 there. I hate decimals. Tell me what the fractional or rational exponent that 0.6 would convert to is going to be. We've got 3 people. Seriously? Alexa? What's that? No. 3/5. So this is 32 to the 3/5 power. Now, if I'm evaluating this out, remember, this is power over root. So the first thing, and if I don't have a calculator, the first thing I want to do is pick which one of those is going to be easier to do. So is it easier to raise 32 to the 3rd power in my head, or is it easier to take the 5th root of 32? Hands up, please, when you can answer that question. Which one can I do now most easily? Sarah? Take the 5th root of 32, so what's that? So now I'm left with 2 to the 3rd power. What's 2 to the 3rd power? Chloe? Done. Next one up, 27 to the 4/3. So I list this out. It's 27 to the 4/3. Looking at what's there, this is power over root. So looking at what I have, what's the 3rd root of 27 going to be? Emma S? And then you have to take 3 and raise that to the 4th power. Hands up, please, when you can tell me what 3 to the 4th power is going to be. You don't have a calculator. You may need to use fingers and toes. You can borrow from others. Hopefully there's enough people in your row. Perfect. Next one up. Oh no, a fraction. You've got 1/9 being raised to the 3/2 power. Which one can we do first? Can I take the square root of it, or can I cube that first? Hands up, please, when you can tell me which one you want to do. Can you take the square root of that first, or cube it first? Alyssa, which one do you want to say? I wouldn't cube that first. I take the square root. That's going to leave you with a smaller value. What times itself is going to give you 1/9? 1/3. And then I'm going to take the 1/3 and I'm going to cube that. Hands up, please, if you can tell me what 1/3 cubed is going to equal. Hands up, please, when you can tell me what 1/3 cubed is going to equal. Seriously? Really? Really? Did you go to some sort of special school where they just taught fractions all day? No? How'd you figure it out so fast? Did you use your calculator when I wasn't looking? How'd you get it? What'd you do? Yeah, and then the numerator. Now, what's 1 to the 3rd power? Do you know that? What's 1 to the 407th power? What year were you born in? 2001? So, what's 1 to the 2001th power going to be? Let's ask this. What's -1 to the 2001st power going to be? Hands up, please, when you can answer that. What's -1 to the 2001st power going to be? Jonathan? Perfect. Because it alternates between a positive and negative. Every even is positive. Every negative is odd. What we're going to have you do right now, please. Yes?
So just a quick thing to double check about getting things straight for 2A. Like, so you did 32 cubed divided
No,
by...
I did 32. I did the 5th root of it first. You want to make it something, you've got to pick. Do I raise it to the power or do I take the root first? It's always easier to make it smaller if the calculator's not there. So I said, what's the 5th root of 32? And that's a 2. And then raise that to the 3rd power.
Wait, 35 or 32 to the power of 5?
No, 30 to the 5th root of it. Not raised to the 5. But what times itself 5 times gives you to the 1/5 power. Okay?
Sorry.
Now, no, that's good. Go through right now, please. You tell me what the answer is going to be in D. Don't go to the calculator. You tell me what's the answer going to be in D. So far, fabulous. 2 of us. Outstanding. Look out MIT and Princeton, Harvard, Yale, DeVry Institute, ITT Tech, University of Phoenix, online. Noah,
4/25.
what did you do first, Noah?
Took the cube root of
Okay, so what's that going to leave you with?
2/5 squared.
Looking at what we've got, you need to understand this. Right now you have a fractional power. There's so much that we can do with this, but I want us to at least see this. Now, you could view this a couple of different ways. There's 2 sort of trajectories we could take. I'd start off and say, all right, I've got 16 raised to the -1/2 power. Now, I like doing it this way. Right now, see how that is raised to the -1/2 power? Remember, when you have a negative exponent, that's the same as taking the reciprocal of the base to make it positive. So this would be the same as 1/16 to the +1/2 power. And now I would evaluate out that. Hands up, please, when you can tell me what that value is going to be. Mandy, what do you say? You've got power over root. Which one do you want to do first? Okay, so 1/16 to the first power is how much? And now you've got to take the second root of that. So what's that going to give you? There you go. That's one way of doing it. Or you could recognize this. This is the same as 1/16 to the +1/2 power. And by the way, what is the 1/2 power equivalent to? Hands up, please. We've established this already. What's the 1/2 power the same as? We have one person. 2. We've already listed this out. We had a discussion on it. We mapped it, the whole thing. Square root of it, so it's the square root of 16. Same answer, more than one way. Go through right now, please, and do the remaining 3. Peter, which one do you want to give? Okay. So I look at this, I start out and say, all right, this is 1/27th now to the +2/3. He took the third root of it, which would be 1/3, and then he squared it, which would be 1/9. Michael, what would you do to begin the next question? Who knows what we could do on this one? Well,
So what we should do is we should put the numerator or the denominator where the numerator is, and all getting rid of the 1 and getting rid of the negative.
so when this goes up to the numerator, when this switches sides in the fraction, this is now 8 to the +4/3 over 1. Now from here, what would we go through and do? Johannes, what do you say? What is that? Let's look at H. Tyler, what would you do in H?
Would flip the fraction to get rid of the negative in the exponent, so you have 16/9 to the 1/2 power. And that's the same thing as taking the square root, which will result in 4/3.
It's not plus or minus since the radical was given to you. If it's from solving, it's a plus or minus. If it's from a given expression, it's as is. Next one's up. These are more. Let's take a look at question number 4. Look at question number 4. we've got to evaluate out these without a calculator. Looking at what I have, if I have a power to a power, which is what's indicated here, it's possible to simplify it. Hands up, please, if you can tell me what needs to get done in order to simplify this out. Well, what's 2 times a half going to be? 1. So this is the same as 4 to the first power, which would give you a. Over here, notice I'm raising a power to its reciprocal power. We would still multiply these together. Now, hopefully, we've got some sharp knives in here. Jensen, what do you go through and get if you take 27 to the, or let's condense the exponents first. What's 2/3 times 3/2 going to give you?
1.
1. So what's 27 to the first power? Next one up, what would we get when we multiplied the C's, the exponents together in C? Allison? By the way, hands up please, you can tell me what 11 to the 0 power is going to be. Peter? There you go. So, if we raise something to the reciprocal power, we would go through and get whatever the A value itself is going to be. Questions on that? Now, here's what our steps are to solve these out. This is called a power equation. And when you go through and you've got a power equation, what you're going to be doing is you're going to isolate your variable, meaning get everything that's raised to that fractional exponent alone. Then you're going to raise both sides to the reciprocal power. We're going to simplify and solve, and we always need to check to see if our answer works. Now, you have it much easier than I because this goes through and checks. You can use fractional exponent notation or radical notation. We'll show you the difference. Take a look at number 5. Our first step is to go through and make sure whatever is being raised to the power is isolated. And in this case, in A, it currently is. So my next step is going to be to raise both sides to the reciprocal power. And Jason, what's the current power that is affixed to our variable that we are trying to eliminate? What's the reciprocal of 2/3?
Yeah, 3/2.
So let's go through and raise both sides to the 3/2 power. So looking at that, these are now gone. It leaves me with A is equal to, this would be 4 raised to the 3/2 power. Now, before I start freaking out or going into the calculator, on the read and on a test, you can always go through to check, but that doesn't take the place of thinking. Looking at what we have now, Emma K., what would you do in order to simplify that out? Take the square root of 4, which is how much? And then what are you going to do to that 2? And get? There you go. Now, you're going to go over to your calculators. Go in right now, please, to a new document, type this in as an equation, verify that this in fact works. Is that true or false? Looks like it's true to me. We did it right. Take a look at the next one. Take a look at B. Taylor, what would your first step be to answer out B? What? Taylor? Not yet. Who can tell me, please, what my first step is going to be? I'm going to divide both sides by 5. I need that term being raised to a power to be isolated. So this is, now I'm actually going to rewrite this at this point. What fractional exponent is currently on the A? Trevor?
3.
Nope.
Oh, sorry, 1.
No. Be careful.
3/4.
Yeah. Power over root. So this is currently what we have. Now on the right-hand side, what's 135 divided by 5 going to go through and give us? Yeah. So we've got this. is equal to 27. Now I need to undo that fractional exponent. And Haley, what are you going to do to undo that exponent? Raised to the reciprocal. And it's a very important distinction. And I'll correct you every time, and I'm not trying to be a jerk, because I know what you're getting at. But we've got to make sure that we say it correctly, because they're very, very, very different things, and you will get eviscerated in the future at any post-secondary school if you go through and you answer and you say it incorrectly, but we get what the spirit of it is. Looking at what this is, we're going to raise both sides to the reciprocal power, so this is both sides now to the 4/3. These are going to reduce out. They go to 1, so a to the first power, or a, is going to be equal to, looking at what's on the right, Emily, what would you do to evaluate this out without a calculator? Which is? And then what are you going to do to that 3? Which would give you? There you go. You can go back and check, but this answer would work. Questions on that? Taking a look at what's here. Now, some of these are easier than others, but you'll see why we square both sides. Take a look at number 6. Looking at 6, Jonathan, what's your first step going to be? So I've got the square root of 3x minus 2 is going to be equal to 4. From here, now, let's keep this in mind. I'm going to rewrite this out now as a fractional exponent. What is this equation going to be rewritten with a fractional exponent? Not radical notation, but rather exponential notation. Who can tell me, please, what this would be if we converted it into exponential notation? We got 3 people. 4.
On the 2x minus 2.
Now, you're trying to get that 1/2 power gone, which means you raise both sides to the reciprocal power. If I raise both sides to the reciprocal power, Colleen, what would you go through and get? What power are you going to raise both sides to? Yeah, to the reciprocal power would beat you over 1 or 2. That's the same as squaring it. Now, Colleen, what would your next line be? Now, from here, Alexa, what's next? Good, so you've got what? So x equals? You can go back and check, but that answer is going to work. Start getting redundant. Let's take a look, please. Let's do out 8. What's your first step in 8 going to be? Now, this is interesting. Look at 8 first. Hands up, please, and tell me what your first step in 8 would be. Jack? He's going to say what? Divide by 2. What's the problem with dividing by 2? What's the problem with dividing by 2? No one sees any issue. Nice and loud, please. There's already a fraction there, so instead of dividing by 2, what can you do that's equivalent to it? Multiply both sides by 1/2. So when we do this, we're going to multiply both sides by 1/2. So what's the new equation going to be, Jack? What do we do now from here? Sarah?
You would make it 1 over x.
I'm going to handle it all at once right now. Let's say I want that exponent gone.
Okay.
Okay, you're not
You
wrong.
can put
Yeah, which would be what?
4 over x.
Now, I always assign the negative to the numerator, but she's right. And she was going to take the reciprocal. It just makes an extra step for us, and it gets sort of more proportionally. So this was going to reduce down. I've got x is going to equal 1/8 raised to the raised to the negative 4/3, which is the same as x equals 8 now to the positive 4/3. What's 8 to the 4/3 going to give me? Hands up, please, when you can tell me. What's 8 raised to the 4/3 power going to give me? Chloe? Do another 1 or 2 of these and then stop. Take a look. Actually, we'll do 2 more. Take a look at 10. First step in 10. Emma S., what's that going to be? divide by 2 first. So now I've got the quantity x minus 2 raised to the 2/3 is going to be equal to 25. From here, we go through and raise both sides to the reciprocal power, which would be 3/2. And when we do that, that leaves me with x minus 2 is going to be equal to, now, who can tell me, please, what I get if I took 25 and raised it to the 3/2 power? You don't need a calculator. You need one to check, but we should be able to handle this entirely without. We've got 3 people, 4. Alyssa, what do you want to say?
I don't know if this is right, but
There you go. Take the square root, which would be 5, cube it, which would give me 125. Oh, what an idiot. From there, I add 2, so x is going to be equal to 127. First step in 11. Noah, what would your first step in 11 be?
Subtract 5.
So we would get 16x to the negative 3/2 power is going to be equal to 2. What would we do now from here, Maddie? So x to the negative 3/2 power is equal to what? Next up from here, Peter, what would you go through and do? No. Who can tell me what he's trying to say, math-wise? He was close. Said multiply by the reciprocal. Yeah. Raised to the reciprocal. There you go. So, what power would that be, Peter? Perfect. So as of now, x is equal to, now this I don't like, so I'm going to change this to be 8 raised to the positive 2/3. So x is going to be equal to how much? Hands up, please, when you can tell me. Seriously? 4? What? There you go. All right, now, let's consider this out and figure out what this graph is going to look like. What's our domain, y-intercept, yada, yada, yada. This is just an exponential function, which I personally have been bracing for so long. If you turn your heads to the back of the room, what is our function? What is our graph that's in the back there? What does that look like? That's an exponential. Notice it levels off. There's sort of what's called a horizontal asymptote, meaning a line it's going to get infinitely close to but never reach. And then as we head out to the right-hand side, it pops up, it starts growing really, really quickly. This is what exponential growth looks like. As I go from left to right, the value is going to either go to positive infinity or negative infinity. Let's take a look. We've got this is our base function. We're going to answer all of the questions accordingly. And you can tell this person stole my function of the week. Looking at what's there, who can tell me any of the any of the y values or the f of x's for this function based on those inputs? We got one person. We'll wait for 9 of you that can tell me what any of these values are. You don't need a calculator. Seriously? 1, 2, 3, 4, 5, 6, 7. You're so excited he's throwing his pencil. I'd be nervous. Chloe. Brave choice. Now, we've got a point that we can go throw on that graph. What point can you go through and fill in now? 0, 1. So closer than 2. Next one up. Michael, what's an ordered pair that would be on the graph? 1, 2 is going to be on there. Johannes, what's another one? So 0.38, Tyler?
X equals 2 would be 4.
Jensen?
Negative 3, 1,
Allison?
Negative 2 is 1.
And this would be 1/2. So you get a graph that ends up looking like this. We've got these here. Now, you have to, my apologies for this being off, because this, it's the pixelation on here. What you have to recognize is this. The graph that you've got starts going through and getting closer like this. So what we have is something that looks like this. technically that's not. So this should be here, what your graph looks like. Now, notice something on this. Let's answer the questions, I guess, as we're doing it, but there should be a little bit of discovery. Which quads is this exclusively in? Hands up, please, if you can tell me. Which quads is this graph only found in? This graph, a pure exponential will only be found, or a parent exponential, will only be found in these quads. Which ones? Which ones, Taylor? First and the second. So what's the coordinates of the y-intercept, Jason?
The coordinates of the y-intercept is 0, 1.
What's the domain of this graph, Emma? Next one up, we need to determine the values of that. What is f of 1/2 going to equal? Hands up, please, if you can tell me. What's f of 1/2 going to equal? You know what this is going to be. You don't need to go to a calculator. Engage your mind. If that's my function, what's f of 1/2 going to be? 2 people. Terrific. 3. Chloe? Nope. Square root of 2, because it's the base raised to the 1/2 power, so that's the same as the square root. Now, what about f of 5? Taylor, what would the f of 5 be? What's that? 32. There's an asymptote. And an asymptote is a line that the graph gets infinitely close to but will not touch. So you write that down.
Mr. Matt,
Yes.
is the graph, or is the exponential, like, graph, is that a parabola?
Nope. It's just an exponential curve. Now, and some of you, raise your hand if you have, well, a sibling. Who's got, okay, terrific, wonderful. Now, you may be this person, or it may be done to you. Who here has gone on a long car trip? Now, has this ever happened? We're sitting in the car. We have an older brother, sister, younger brother, sister, what? Younger sister. So she's going to sit. She's sitting next to poor Jack, right? He's just sitting there sitting there going, you know what? I heard this McAtee is amazing. I'm going to watch some of his videos so we can get ready for class this summer. I really hate that we're going to Disney. I'd rather be at home watching Matt's videos all day. So as we're driving down to Florida, is your sister annoying sometimes? Or what was she? Seventh grade? They're the worst. Middle school people. So they sit there and they go like, okay. Now, what are you going to say to your sister? Yeah. Who's got a brother or sister that's done that?
Oh.
And what do they do? They go like this, right? And what do you say? Don't touch me. And then what do they say? Do not touch you. An asymptote is annoying brother or sister. It's getting infinitely close to it, but not touching it. And it's a very important step to go through and get. And I think that, I don't know that this is what it is, but there's something called, I don't remember the name of it, I think it's called the Archimedes counting principle, but I'm probably wrong. That it's possible for me to walk from now until the end of time and never reach the door. And an infinite number of iterations of walk. Like I could constantly be in motion, but never reach the door. And the way would be that if I went through and took half of the distance to the door as each of my journeys. So let's say I'm 10 floor tiles away. After my first trip, how far away would I be? 5. We'll do this on, okay. So we'll do that on 8 tiles away. I don't want us to work it out anymore. So we're going to go through. So I'm 8 tiles away. After my first trip, how many am I away? 4. After my second trip, how many am I away? After my third trip? And then? A fourth and 8 to 16. And then people go, well, eventually you're going to get there. If I am down to where there is 2 atoms between me and the door, how far am I going to move? 1 atom. And then I'm down to 1 atom. And you're thinking, it's got to be it. Next step, I'm so close. Now I'm half an atom away. And now I'm a fourth of an atom away. And now I'm a 16th of an atom away. Am I ever going to reach the door? No. An asymptote is the same thing. It's going to get infinitely close to. Now, the distance between me and the door is going to be insignificant as we go out to infinity. But that's what's happening. So what's the equation of our asymptote in this graph? Be very careful. Hands up, please, if you can tell me. What is the equation of the asymptote in this graph? Seriously, 1, 2 of you? How did we get through geo? What's the equation of the asymptote, the line that this gets infinitely close to and doesn't touch? 4 of us? Jason?
Y equals 0.
There you go.
Oh wait, it never touches that, so how...
Right, that's an asymptote.
Oh, that's the asymptote.
The one that it gets infinitely close to and doesn't touch. What's the range of this graph going to be, Trevor?
It's going to be 0, but with the open bracket to positive infinity.
As x goes to what? F of x goes to what? So, let's pick. Haley, do you want it to go to positive infinity or negative infinity first? So as x goes to positive infinity, what are the function values going to? And as x goes to, Emily, negative infinity, what are the function values going to? No. Who can tell me? Nope. 0. As we go out to the left, what's the function going to? 0. It's leveling off. Is the exponential function increasing or decreasing? That's going from left to right. So which one is it doing? Yeah. It's increasing exponentially. Looking at what's there, is there a relative or absolute max or min? We can answer one of those. Is there an absolute or relative max or min, and explain your answer? So which one of those can we go through and say? Okay? Now, I'm going to say this, and it's very interesting, because she wants to say that there's a minimum, and what minimum are you saying it goes to? So we'll say this. Is there a relative or absolute min? So we're going to say this. Relative means local. Absolute means everywhere on the graph. So is the min she's talking about, is it a local min or an absolute min? Which one? Which one? It's an absolute one. So we'd say there is an absolute of Now, yes, there's a big kid sentence in there. Grow up. I'll take that AP English so much. Right? Tell Mr. Paula that we used a complete sentence in English class or in math today.
I am in non-English English.
Do you have Mr. Paula?
No,
All right. Well, he's nice too.
what about absolute maximum?
Is there one?
Yeah.
Nope.
But it goes to infinity.
Can you hold infinity apples?
Oh, no.
That's the test. Is there an absolute maximum? No, because no matter what you get, you can always add one more to it. And that's a good thing that you need to understand. Because there's a concept when we go on to pre-calculus next year, you're going to deal with a concept which is a limit, which is look at what the function values are going to. And a limit does not exist if the graph goes to infinity, because it is not a number value. And that's for mean girls, the limit doesn't exist. Now, this is it. Take a look. We're going to bounce over. This function right here, by the way, if we did this? We'll fill in the table quickly. Looking at what we have here, who can tell me what's one coordinate that would be on this graph? Hands up, please, if you can tell me what's one coordinate that's on this graph. Seriously, 4 or 5 of you? I love it. Love when we take that one right away. Because next year, when I go through and give this out in pre-calc class, every year, that's the last one they fill in. And it hurts my head. Because there's 2 of them that you should be able to give right away. What's the other x value that you should give instantly?
1/1.
Thank you. And I'm like, so what other values can we fill in? And they're like, I don't know what 1/2 to the 0 is. And that's when I have a stroke and fall on the ground. Jonathan, what's another value we can fill in?
21.
What do you get? Perfect. And this would be 4, this would be 8, this would be 1/4 and 1/8. So as we do this graph out, now this is just a sketch. You all are actually going to give the real deal graph. So go through right now, please. You give this graph on your paper. This is exponential decay, just so we're aware. The last one is broke. Go through and give the actual graph. I know that I shortcutted it. You don't. Give the actual graph completely. And you can answer the questions subsequent on your own. It's not that different than what we've done so far. So go through, bang this out, make sure you label it as decay. Let's bounce over, please, to the next one. Are exponential functions 1-to-1? Let's answer those questions. Is an exponential function 1-to-1? Hands up, please, if you can answer that. We did this previously. Is an exponential function 1-to-1? We did got one person. Take a look at the graph, even in the back of the room, if you need to see it. Is an exponential function 1-to-1, and why? Colleen, what do you say? Why? Absolutely correct. So we're going to start off and we're going to say, and yes, we're going to use big kid sentences. And here's another thing. This is probably me, and I'm not trying to be a jerk about it. You all need to understand that we're prepping you not to just casually make it through the math program. You're actually, anything that we can do to get yourself ready for calculus now, we're going to do it. One of the things, and I think, I don't know if we talked about it previously, you have to understand that on the AP exam, they are merciless with your language, to the point where we spend at least 2 of the AP classes going over how specific your language needs to be. Don't use words like it. That's why I've tried to make you go through and stop saying you set them equal to 0. Is that called a pronoun when you use like a non-descriptive identifier like it or them or something like that? So stay away from pronouns. Use actual I don't know, that's not a proper name, but use the actual names of things. So let's say this. We'll say, yes, the function, or we'll say, yes, exponential functions are 1-to-1 because they pass the VLT and HLT. That's a lazy definition, but we'll let it slide. The Reg lets it slide. What does that tell you, or how can you tell? We look at the graph and we have eyes. What do we know about their inverses now? Who remembers this? Because this is one that we're going to start hitting very, very frequently. What does it tell us about their inverses? I don't mind that abbreviation. I don't need to write out ONE to ONE. You can write the number 1-to-1. Given the function before, now here's our function. The g of x we need to go through. So that's our f of x. The g of x graph is equal to the f of x graph minus 4. What does that cause us to happen? What will the g of x graph look like? Does anyone know? We got one person. We've discussed this previously. What's going to happen on the g of x graph, Tyler? So what would be, so that if we need to do, we literally take all of the points, go down 1, 2, 3, 4. Okay, something like that. See how good my exponential is. Holy, I mean, wow. Just so you know, you all saw that I'm not, whoa, I'm not lying. That was freehand that I did that. Can you believe that?
On your screen.
I know, so all of humanity can watch. I mean, look at how impressive. Can you even come close to that, Jack? Is your graph going to be as good as that graph is? Can anyone's really be as good as that graph is?
Not even in my dreams.
There you go. If I gave you a computer, you couldn't be as good as me. Now, what we're going to do, maybe over here it could be a little. Whatever. Don't yell at me, please. Now, oh. 4. So it goes 1, 2, 3, 4. So your graph should look something like that. Now, what is the y-intercept of this g of x going to be? Hands up, please, when you can tell me. What's your y-intercept of the g of x? Tyler?
It was,
Compare the two. What effect did subtracting 4 have? Shift it down 4. Does the exponential function increase or decrease? Which one is it? What's that? Look from left to right. It's going to increase. For what values is that function greater than 0? Now I'm going to ask this. Where does this graph go through the x-axis? Hands up, please, if you can tell me. Where does this graph go through the x-axis? Do I have it right or not? I don't even think I do. I don't. It should be at 2. Mine was a little bit off, so we're going to see. I mean, if you did yours accurately, like I told you to, you take all the points, shift them down 4. Where is this graph? Where is the g of x graph going to be greater than 0? Who can tell me, please, where the g of x graph is going to be greater than 0? Where is that graph greater than 0? We got 1, 2, 3 of us. Oh, come on, loves. Get real. Peter? He's absolutely correct. That's outstanding. That's why the accuracy matters. I'm sorry. I can't be cleaner. What's the equation for the asymptote in that graph? Hands up, please, if you can tell me. What's the asymptote equation going to be? Fabulous. What's the domain of it? Negative infinity to positive infinity. Our range, what would the range on this graph be? Hands up, please. Yeah. Parentheses, -4 to positive infinity. We go through and give our end behaviors. X goes to, Y would go to, and so on. Now, I'm going to tell you this. You have that sheet over here on the side. If I'm you, I would do this. If I'm you, I would do this. I would handle out maybe the evens from 1 to 60. Maybe the evens from 1 to 60. These should be instantaneous, as in this is not trying to take you longer than 10 minutes. The packet that you picked up in front. Then the other thing that I would do is this. Take a look, please, at 87 through 112. I gave you these for a reason. 87 to 112. I would do every third or fourth question in there. And maybe 1 or 2 of those are applying the concepts one. Because those are the questions you're going to be facing when you come back. Don't be mad when I don't let you use the calculator. Have a great rest of your day. You did. Oh, by the way, you might want to fill in what your day is on the front of the calendar that we had, just so you're aware. Today was day 2. Oh, and for those of you missing, because we're going to miss next class, you're still going to have to watch the video, but the bonus is we don't have class the next day. Who is going to be here? I think there's only going to be 3 or 4 of you here. We'll still go through and do it. We're still going to have class. You're going to have to watch. I'll post and send it out to Remind, Google Classroom, etc., etc.
Well, let me put that in.
Yeah.